should see something coming up. Okay, so basically, I gotta do attendance real quick. Okay, so who's here? This is physics one. Okay, we still don't have Aldo. Danny's here, so gotta follow up with them too. Okay, so let's go to the problem, and you should be in physics two, and we're doing work and energy. So, Dan, did you copy this part of the problem? Can you see what I'm doing?
Yeah, I copy that part. Yeah.
Okay, so you already got the Google Doc, I think. Right.
Yeah.
Okay, so let me hurry up and catch up to you. So we start with our name, our header, and the date, and it is 2020. Then also this is period two. This is for physics. All right, so that's our header, and then the title you can just call it the do now. You blow this up a little bit, and then and like I said, try to get in the habit of resizing your screens. So all you gotta do is click somewhere in this space to blow it up or shrink it. But let me go back to this. So I'm trying to make sure the screen is presenting right. Okay, it is presenting right. Couldn't see my monitor screen. All right, now it's at 125, so it's pretty big. And then we put the problem in. Oh, that's the Google link. I was trying to help out Miss Hints a second ago. So that's why I do this. Copy it again. And now I think I'm about caught up to Danny. That turned yellow for some reason. I'm not gonna worry about it. So that is what I want to go this way, and I see why I did that. Okay, there we go. Now we're gonna start off with what we know about the problem, and we first got to understand what work is. So the problem is, and I forgot to tell you to put your title. I mean, your the name your document. So you're gonna call this the do now for, because this is how you find the document once you save it to your drive. So do now for the 13th of July, 2020. All right. So now that I got that, I can begin moving into what work is, right? So what is work? Well, this is from earlier today. Work is simply this equation here. Now, there's other forms of work because it's all joules. You have kinetic energy, you have potential energy. So, in a lot of cases, horsepower can be joules. So, this is a quick note, right? Now, we're going to use the actual equation in the problem set. So, oh, I minimized it. I didn't want to do that. Here we go. And that's going to be work equivalent to, well, hold on. I could just pull this from earlier. So, work is going to be equal to the force multiplied by the distance. Okay, so you got that much typed up, Danny?
Yeah.
Okay. So I'm gonna put two more things here because I want to explain it out for you. And these are your notes to do the work or to calculate what you're looking for in this section. So that is work is equal to the force multiplied by the distance. Work is equivalent to, if you're noting it, the joules in the problem, and then If you're talking about force, when we measure it, it's in newtons here. And then distance is going to be in meters. Okay. So with that said, a shorthand way mathematically of writing it is W for work is equal to the force for F multiplied by the distance, and it's always lowercase d in meters. All right, so far so good. At this point, we need to set up our known and unknown values again. So what do we know? It's the next thing you want to type up. What do you know? Well, type known. Come over here. No. All right. So let's think about it. What did the problem give us? That's the known value. Well, if we look up here, the first thing they say is there's a species. Well, I didn't read the problem off. I'm gonna read the problem off for you, I guess. There's a species of Darwin's finch on the Galapagos Islands that can exert a force of 412 newtons with its beak as it cracks open a seed case. If its beak moves through a distance of 0.52 centimeters during this operation, how much work does the finch do to get at the seed inside the case? So it's a small little seed, like you can think of it like a sunflower seed, but the finch, which is a bird, is trying to break through that shell to get to the seed with a certain amount of work. So the first thing they give us is that this finch or bird, it exerts a force. A force. So that's F. It's equivalent to our 412 newtons that the problem told us about. And come over here because I'm going to come back to it. And we got to like talk about what is the question asking us or our unknown. So the next value they give us is the distance. And it's lowercase d. See if that works. Okay, good. And that's going to be 0.52, and this is called centimeters. Oh, they did it for me. I didn't know it was going to do it. So that's fine, but in order to calculate work, you can't calculate work with centimeters. You got to know exactly what centi means and change it to its numerical value so you can use just meters. So if you take a look here, and you should have bookmarked this a while back, centa is equivalent to 10 to the negative 2. That's basically its base, but its name is 10 to the negative 2. And these are the prefixes, by the way, when you say centa. What base is it? And that's going to be that. So in order to convert that to just meters, I would need to take the problem again and write it without centa. Write it with its base name or base definition. So I'm going to put this here. And instead of centa being there, this is going to be times 10, right? And we said it was to the negative second power. Okay. Now, work, right? That's what we're calculating. How did I know that? Because if you look at the very last part of the statement, it says, how much work does the finch do? Well, that's W. And it's equivalent to some number, so put question mark, in joules. Okay. So far, so good, Danny. You still with me, or did I lose you somewhere?
No, I'm still with you. I'm just writing the last part.
Okay, so you need a second to type it up because I'm
Yeah,
looking.
just like 2 seconds.
Okay, so I'm gonna give you 2 minutes to finish typing. If you need more, let me know. But you get, you're here on time, so you get that privilege to take as much time as you can. 'Cause the goal is to have this finished so you can submit it later. Okay, let's see here. So, how far you gotten, Danny?
I'm done.
Okay, so let's finish it off. We're gonna move on, and when we do this, we want to now put it into the calculated form, which is this equation here, right? That's why we set this up so we can begin calculating it. And luckily, you don't have to do any algebra. You would just put this inside of your F for this value, force, and your distance would be this value. Because remember, we got this from the problem above, but we have to use this down here because it's in meters. And when we calculate it, it has to be this setup. So newtons times meters, not centimeters. Okay, so what do? We take the equation, which is the tool we're going to use mathematically to calculate for our work. This over here, and work. 1 second. She's from a different country. All right, and that's equal to our 412 newtons multiplied by our, and we said we're using this up here, so I'm just going to use this, and close parentheses, just because keep it sound and mathematical. So the next thing is what? Well, we're just rewriting it because remember, newtons and meters are going to combine. And when they combine, they make joules. So let's group the numbers because we still got to calculate it using symbol lab. That's going to be our 412 here. And I'm going to come down and put that there. And this is going to be multiplied by that value here, which is 0.52 times 10 to the negative 2. That there. And what becomes of all this? It's now just joules, right? So what do we do now? Well, all we have to do actually is go to symbol lab. Let me do that. So symbol lab is right here. And as I said, resize your screen so you can have more workspace. And I want to find out what that's going to become. So I'm going to say 412 multiplied by 0.52 multiplied by 10. And I can click on this here to raise it to the power of negative 2. Okay. So what does that become? Well, if we look here at the answer, it's 2.14, right? So 2.14 work is equal to 2.14, and it's in joules. And that's the end of the problem. Okay. So you want to take a minute to finish typing this up, and then I was going to do some practice problems of substitution method for Isaiah's, which I think also might be a good idea for you too, because you guys have a quiz coming up on Thursday. And you should have all of the do nows we've done together typed up and still available. All I'm going to do is, if you see a similar problem, I'm going to pretty much change the number values. So it's not difficult. It's real easy if you have all the notes dandy and you just go through your notes and find the particular problem. You got to recalculate. You can't type the same stuff up, but you got to use the same steps. So,
Uh,
so take a moment and finish typing this up. Where are you at with that? Are you almost through or no?
yeah, I'm almost right. I need like not even like a whole minute.
Okay, so as soon as you're done, let me know so you can share your screen and I can make sure you get it all submitted. I mean, all typed up, and then I want you to
Yeah.
hurry up and show me how you submitted it, so I don't have to worry about if she turned it in or not. You know.
Hmm. I'm done.
Okay, so I'm gonna stop sharing, and I want you to share, Danny, what you got going on. Okay.
Alright.
Okay, there you go. I'm seeing something. Okay, let's see what you got here. All right, scroll down. Okay, okay. There you go. Awesome. Okay.
Okay.
All right. So now you're not off the hook yet. Don't you? Slow
Okay.
down, girl. I want you. You about to close the screen. All right. So I want you to real quickly go to your Edsby. Did you name your document first, Danny? I
Oh,
saw.
so you want me to download it, right?
Well, first name your document so you can find it. So call it "Do Now," like I did. Do now, and just put the date. There you go. Enter. All right, good. It's saved. Now you're going to do the file. Download as PDF. All right, let's see if you
Yeah.
can get this into SB. Okay, you know what to do. I see you moving
Yeah,
now.
and then what was it?
You got the hang of it. Okay, okay, and submit. That's it, Danny. That's it.
Yeah.
Now, the only thing we got to work on now. You can stop sharing because I know you don't like sharing. You be quick to turn it off. The next thing we got to do is, did you finish the substitution method problems? All the worksheet.
No, not all of them.
Okay, so you're gonna need to open it in a Google Doc. Like, do you have
Uh,
notes on what you did do?
yes, should have them.
Okay, so did you start like what happened to the assignment I gave you? Not the assignment, the do now I did with you. That was a substitution method. Do you still have that saved? So let me
Yeah,
pull it
I
up.
should. Let me see if I can find it.
It was
So,
for July 9th, I think, right?
um,
So let me share my screen in a moment because I'm doing a quick data talk with you before I give you a 5 minute break. I'm just gonna do some of these substitution problems so you can at least try to understand some of it. So Thursday won't be hard on you. Let me share my screen, entire screen. All right, so let's see here. You should see what I'm doing.
yeah, I
Yeah,
see.
okay. And if we're in physics, yeah, we're in physics two. If I come down to July the 9th, because Isaiah had asked about this one as well. Are you still there, Isaiah? So you uh taking a break?
No, I'm here.
Okay, so I don't know if you want to pay attention to this. We're going to switch gears and go back to substitution. Um, this is not one of this was a sample problem that we did, Isaiah. That was just to give you practice because it was like almost out of time. But I'm going to do one other problem from the substitution method. We did a video on this right here, and it will come back because I'll give you different fractions, and it'll be on the quiz. So go through your video and see me do this problem. But I'm gonna do something simpler. When it comes to the PDF that I gave you, which is worksheet problems that I told you you had to finish. And if you remember, I told you I think it was what 1, 2, 6, and 7, right?
Yeah,
Mhm.
So I think we did what 6 and 7 together, right?
yeah,
Yeah.
You have that in the video, and I think it was either period one or I think it might be period two. But check that video. It says physics two on that date. But then there's this one and this one. So out of these two, which one do you think is the most difficult? Let me blow this up a little bit if I can. Let's open that up. All right, and you can see a little better. I hope. So which one you want me to do? This one or this one? Because you guys have these two.
I say do the first one.
The first one.
Yeah.
Do you know they're both equally easy to do? They're not difficult at all.
Mhm.
So I'm gonna do this one, and then I'm gonna do this one. If I have to, well, let me do this one, and I want you to still do this one on your own. So let me do this because you only needed these two done, but I'm gonna try to get two examples in before we run out of time for you to begin practicing it for Thursday. Okay, so first thing I'm gonna do is I'm gonna start with a new Google Doc. And if you haven't typed these up, you might want to include the notes from the video into this new Google Doc because you guys are trying to get this done too, it seems like. So open a doc, blank, and we're gonna type up our document title. So it's substitution method. And this is for uh July the 9th, right? So the 9th of July for me, you type it how you feel in 2020. All right. Now, so what I'm going to do now is I'm going to take the problem I said I was going to work on, and I'm going to just type it in. First, I need my header and the date, which I said was going to be July 9th, 9th of July, and 2020. So this is period. You can say period one or two because they're both physics. Danny, I think it's two. For Isaiah, it's one and two. So this is solving a system of equations. And I take that and put it in there. Just let you know what you're doing. It worked. Okay, cool. And the problem is going to be equation one. And that equation is what? Well, we say we're doing number one, so that's going to be that y equals a negative, the fractionary 1 divided by 4. And this is going to be plus 6. Next, we're going to figure out, we're going to put in what equation 2 was, just so we'll have it so when we're ready to use it, which is going to come up really soon. And that's simply, and that's why it's so easy. They only gave you y equals 4. This is the easiest one that I gave you to do because all you do is this is already solved for y, then you have y by itself. And I say that because if I put an x there, it's not solved. But since it's already got just 4 there, a number value, you can take it and use it again into equation 1. So what does that look like when we're substituting? So substitute, right? I didn't spell that right. Why don't you move? I got it. Move out the way. Thank you. Substitute equation 2 into equation 1. This is the y value that equation 2 gives. So what does that become? Well, if we take this, highlight that, and put this here, we can then say what? Well, when we rewrite it again, we know this is equation 1. Let's just be clear. And I'm going to now change it with equation 1 and 2 to combine, because I could put y in, put 4 in for that y. So that's going to be 4, our new value. And instead of putting it in a fraction, you can just say what it is. So use your trusty calculator if you're not sure, but 1 divided by 4, that earlier that was 0.25 or a quarter. So I can say that's going to be a negative, because there's a negative sign there, 0.25. And x, because we still got to figure it out. We don't know what that is. I'm just rewriting it. Plus 6. Now, this is basically going to be saying this is equation 1 combined with equation, substitute to equation 2. Okay? Combined with. Okay? So what does that mean? Now, this part, now solve for, if you look there, we're only solving for x using algebra. Okay, so let's begin with that. We're going to take this equation that we've combined by substitution method, and we're going to begin by putting it here and doing some algebra on it. So the first thing we want to get rid of is this plus 6 value that's next to the x. So we got to do some algebra, move it over. Most students would start off with removing this or dividing. That would not fix your problem. It'd be a legal move because of your order of operations. So take this here, plug it in there again, because now I'm about to make some changes to it. What I'm going to change is I'm going to need a negative 6 here. This is a positive 6 there. And I want to do what I do to one side, I want to do to the other. So how does that change the situation? This negative 6, let me just make sure you know that's the change to the actual problem. There we go. And blow this up a little bit. That's going to be the change. And then I'm also take this change, and when I do to one side, I do to the other. Okay? So everything in red is a changes that I made. Now, what happens? Well, on this side, if you pay attention, these two will cancel out. That'll be through the algebra process, plus 6 minus 6, or 6 minus 6. That's going to be 0. So that part of the equation goes away. And we end up with a new equation that looks like this, only you're rewriting simply just what you started with. Okay. Now, normally you would want to rewrite this from right to left, or I'm sorry, left to right, where x is on the side, but it's still the same in case you're wondering about that. And there is still a negative sign there. So we still get x by itself. And we need to remove, because this is like saying negative 0.25 multiplied by x. So in order to get rid of that 0.25, we have to do the reverse of multiplication. And that would be simply making a division bar, and then making a division bar over here too, and dividing by what we don't want. So in that case, it was our negative 0.25. And what you do to one side, you do to the other. And we started over here because we want to get rid of it. That's also negative 0.25. So just cleaning it up for you guys, gals. So what does that mean? Well, if you look here, these are the changes that were made to the problem. stay consistent. And this negative 0.25 will cancel out with the bottom one. So format strike through and format strike through. As you can see, the x is unaffected. It's going to be multiplied by 1 because these two will divide out and leave 1 times x. So now when I come back here and turn this stuff off and strike through as well because it's going to carry over. Okay. I end up with a new equation of x equals, and remember it's two fractions that this will, become, because it's like saying negative 6 divided by a negative 0.25 and 4 divided by negative 0.25, or yeah, 0.25. So negative negative will cancel. That just leaves 6 over at 0.25. And then that negative will reverse to positive 4 because of the negative 0.25 in the bottom. So it'll be minus 4, right? And what it divides by is the 0.25 in its own unique way each time. So we're going to do that. And that looks like what? Well, if we're doing it slowly, it's going to be, again, the 0.25 here, right? Because negative negative cancel that. And then again, it's going to be the same thing underneath the 4 and in denominator for the 4. So now that we have that, we can begin by, dividing this out. And since there is no x attached to it, Symbolab should work okay for it. So I'm going to come here and remove the fraction and I'll make a new one because we got two fractions to calculate real quick. It's going to be 6 divided by, right? Because that negative is gone. No, I didn't want that. I wanted you to do something else. Okay, there we go. Divided by 0.25. And then this is minus, let's put another fraction there. And what do we get? We have 4 here and another 0.25. The answer becomes what? Well, if you look here, it's just 8. Okay, so just did that because it's a quick tool to help you get some of the work done. So x is equal to our 8. And our ordered pair, if you pay attention, since they gave us y a long time ago, is simply ordered pair, which is usually written as x comma y, is, you make some parentheses and just do what I did. That's going to be our x, which is 8, comma our y, which, if I think we remember, is 4 above. Okay. So that's pretty much it for that for that number 1 problem. Now, it's 10:44. Do you need time to type this up? Because I was going to jump into the next problem, which was, what did I say, 7? Do you guys see all this? Does it make sense? Hello?
Yeah, it makes sense.
Oh, okay, okay. Yeah, say something. I thought y'all were, what you guys is? He's still working on something else? Oh, there it is.
Yeah, I just finished that.
You said hold it there for a second?
No, I just finished.
Okay, so now I want you both to submit it, and I'll be looking for it right now, at least that part, and then go back and finish the rest of it. But I want to grade that part to give you some points on it because you got a 0 sitting for that. So
Wait, because I typed it onto like the original doc. So should I just copy paste into a new one?
to you can put it in that, you can leave it in that format, and if you're not done with it, you can send it in. I was just saying, don't forget.
Yeah. Yeah, I just need number 2 anyway.
You guys need me to scroll up or down on here, or you got it?
Oh, you got it.
Okay. All right. So I'm gonna set the clock for 5 more minutes, I guess, and then we do data talks because it's like 10:46, and it's not enough time to do another problem. You guys still typing this up or no?
Yeah.
No, I'm done already. Though.
You're done with it? Okay.
Yeah, I'm done.
And what about you, Danny? You say you still working on it or no?
Yeah, I'm almost done.
Okay. Okay. All right. So Isaiah, I know we're gonna talk computer science next period. If that's it, I want you to try out that other problem, which uses the same thing I did here, and get that submitted hopefully tonight, so I can make sure you get a higher score than zero. And then don't forget to add or include in this document the very first problem that I did a video on. It was the one inside the problem before you got to the worksheet. Okay, but take try to come back at what was it 11 because that's our next period. I have you try to
You
come
have
at.
Danny too.
You said what, Isaiah?
You have Danny too.
Yeah, I still got Danny, but I think she's. I'm just gonna do a Danny. Do with Danny a data talk. But with you, I think we just gotta work on computer science. So I'm giving her time to finish up. But like I said, you could take off for like however long and come back at 11:10, and that gives you a sufficient amount of time to break before we start on computer science.
Uh,
Okay. Okay, Danny, you finished or you need a little more time?
I need like 2 more minutes.
Okay, that's fine. I'll set a clock for 2 minutes and then I'll check on you again.
Alright.
Okay, Danielle, how you doing?
I'm done.
Are y'all done? Okay. All
Yeah.
right. So don't forget, like I told Isaiah, to go back and try some of the other problems. I know the videos, the ones you do, 6, 7 from the worksheet, and then
Hmm.
I did one here, and two you got to do on your own. But
Okay.
check the videos so you can get all that submitted, hopefully soon. Um, do you have any questions for me? Like it seems like you're getting the hang of the class again.
No, not that I can think of at the moment.
Okay, so quick announcement. I think all classes are done July 30th,
Okay.
and you have a quiz coming up Thursday. So go through all the stuff we've done. Go through the videos in the library, and try a lot of this stuff out. So you won't be looking at the quiz all crazy and stuff. Okay.
All right.
All right. So that's all. I want you to go ahead and get ready for your next class, and use this time to I don't know. I think somebody else is coming in. Use this time to like try to refresh and get ready for your next period. Okay.
Okay.
Okay. Now, who is this coming in the room? Oh, he made it. Are you
What's
on
up?
Are you on a computer, sir?
Yeah.
Okay, hold on. Let me look up your schedule. He made it.
Yeah, man.
The man with the plan. Welcome. All right, 1 second. Mr. Brown. And congratulations again, dude. But I don't know. I hope you can get this stuff done so you can keep that. Congratulations. Let's see here. I'm trying to get the search bar. Here we go. Brown. This gentleman here. So I'm gonna tell you what happened. You came early, sir. So
Early.
early. You were supposed to be in algebra a moment ago.
Yeah, he just told us to leave.
Oh, he let y'all go early. Okay, so use this time because I'm not gonna start the class till 11:10. Hello, who's that?
Yeah, okay. That was my mama. Hold on.
Okay,
Hold on real quick. Hello?
hello.
Yeah, my bad.
Okay.
Hey, why I can see other people then if I'm early?
Because there's still some students that like have 2 and 3 periods. Like Mr. Isaiah, he's in periods 1 through 3 with me. Physics 1, 2.
Oh, okay. So
Yeah.
what about with you?
Where to what?
Where about? How many classes I got with you?
You only got one with me.
That's a lie they talk. Yeah, that's London. This Zay right here, but that was just London.
Hey guys, hey. No, you got one period with me, which is coming up next.
Okay.
Then you got civics with Mr. Rollins at 4.
So I'm not supposed to be here until like 11 o'clock.
Yes, 11 o'clock. But I'm giving you to 11:10 because I know you've been through classes, and then you guys a moment to stretch, use the bathroom, reset.
Okay. All right, yeah. All right,
Okay.
I'm finna hang up.
Okay, just come back 11:10.
He know what. All right.
All right.
What's Tyler?
Miss Hills, how you doing?
Is this my class next?
It's computer science, yes. It's coming at 11 though. But I
Okay.
know you guys been through a series of classes. Michaela, I got you for third and fourth period. Okay, so
Okay.
what's gonna happen is I told everybody to come back. You can stay in the room, but get ready for class at 11:10 because I'm trying to get everybody a chance to stretch your legs and
All right.
do what they got to do. So be here at 11:10 and we'll start class.
Okay.